Section 4.7 starts the optimization. So optimization in this class, we're trying to use the derivative to find the maximum or minimum for different application problems. So we are going to try and find like a local max or a local min. Number one, it says an island is 4.5 miles from the nearest point on a straight shoreline. That is 10 miles from a power station. A utility company plans to lay electrical cable underwater from the island to the shore and then underground along the shore to the power station. Assume that it costs $2,800 per mile to lay underwater cable and $1,500 per mile to lay underground cable. At what point should the underwater cable meet the shore in order to minimize the cost of the project? So I definitely want to draw a picture here. And I'm going to call this distance x, and then because of that, I know that I can call this distance 10 minus x, because I know the entire length there is 10. This is a long problem, so we can figure out the hypotenuse there. So if you use Pythagorean Theorem, x squared plus 4.5 squared is equal to c squared. So the square root of x squared plus 20.25, if you actually square 4.5 to get c. So this will be what c is equal to. Oops. So if I take that, that will be my hypotenuse. Okay. So let's talk about the cost. So the underwater cost. I want to take the cost per mile times the number of miles. So I know that it is 2,800 per mile, and I know that it is going to be square root of x squared plus 20.25 miles. So that'll be my underwater cost. The underground cost I know the cost per underground is 1,500, and I know my distance is 10 minus x. So then the total cost this is going to be c is equal to my first one plus my second one. And I'm going to rewrite this a little bit. So c is going to be 2,800, and I'm going to call that x squared plus 20.25 raised to the 1/2 instead of the square root. And then I do want to distribute the 1,500 to be 15,000 minus 1,500x. And this is what I'm going to call my original equation. So I mean, we've done a lot of work to get this, but we we haven't taken any derivatives or done any other kind of work like that. So I'm going to call this the original equation. So my next step is going to be to take the derivative, because I want to find the critical numbers, because those can help me get the minimum in this case. So C prime is equal to 1400 times x squared plus 20.25, and then using the power rule that changes to negative 1/2, and then I also need to multiply by the inside, so times, or I should say the derivative of the inside, times 2x. And then this will be minus 1500. So then if I rewrite this, this is going to be 2800x all over. So I'm combining the 1400 with the 2x, and then I actually want to move the negative 1/2 of that, or I should say the x squared plus 20.25 raised to the negative 1/2. I'm going to rewrite that as square root of x squared plus 20.25 on the bottom, and then minus 1500. Now what I want to do with this is I want to set this equal to 0 for the critical numbers. So let's see, I don't have enough room. I'm going to start back up here. So I have 2800x over the square root of x squared plus 20.25 minus 1500 is equal to 0. So I'm going to actually move that 1500 to the other side. And I'm also going to call it 1500 over 1. So at this point, I actually want to find the cross products. So this is a proportion, which means we can find or solve the cross products. So this is going to be 1500 times the square root of x squared plus 20.25 is equal to 2800x. If you divide both sides by 1500, then x squared plus 20.25 is equal to 28 over 15x. Next I want to get rid of that square root. So what I need to do is I need to actually square both sides. So if we square both sides, then we're going to get x squared plus 20.25 is equal to, that's going to be, where am I at? Looking at my notes. It's going to be 784 over 225x squared. If you subtract x squared from both sides, it's basically like you're subtracting 1 x squared. Then this is going to be 20.25 is equal to 559 over 225x squared. So if you take your calculator and do 784 minus 225, then you will get the 559. Looks like I need some more room, so I'm going to erase this. This is the first time I've had to erase on one of these slides. There we go. And then I'm going to erase that. Okay. So the next thing I want to do is I want to multiply. So I want to times both sides by, well, we have 559 over 225. So if you multiply by the reciprocal, so by 225 over 559, then you should get 18,225 all over 2,236 is equal to x squared. And then you want to, again, we're trying to find x here, so we need to square root it. So it's not often a problem where you have to take the square of both sides and the square root of both sides, but in this case it is. So I have plus or minus square root of 18,225 over 2,236 is equal to x. And I don't really care about the negative. So if you forget the negative, then x is going to be equal to 2.8549. So I mean, this will be our answer, but we have a lot of things we still need to do. We actually need to prove that this is a minimum. So in order to prove that this is a minimum, we do need to draw it on the number line. So 2.8549. And you do need to plug in numbers into the derivative. So if you plug in test points, you'll find that this is negative, and you'll find that this is positive. So this is our minimum proof. So without this, it's just a critical number. It could be a maximum, it could be neither, but we really need to prove that it is an actual minimum, meaning it changes from negative to positive on the number line. So I do want you to show this. Okay, so my final answer is going to be 2.8549 miles from, that's phrased as from the nearest point to minimize the cost. So that, after all of that, is our final answer. Okay, we made it.